sat down this morning, did a little bit of work, fixed some of the puffer boxes that were down. And then I realized that I wasn't really feeling like doing some of the low-level nitty-gritty stuff that I was going to have to do. So I figured I'd just flip things around and work a little bit more on this now. I thought of a way to get around the annoying model loading thing that I was looking at yesterday. Will require some kind of substantial changes to PufferLib, so it's going to take a few days before all this gets merged into... I can probably merge it into dev, but before it gets merged into main, it'll be a little bit. But yeah, let's just start from there. I found a... Okay, Chris, you can fight me on Twitter as much as you want, but this is just wrong. This is because the baselines are horribly tuned. You do good work, though. I will give you that. Where's the thing that I posted? Because I found a nice way of putting it. This is what I want to answer with this project. Is continuous control fundamentally harder to learn than a discrete action space? And I think that the way to answer this problem is to sort of separate continuous control from what people think of as, as continuous control being robotics. So just fundamentally, if you make the action space continuous, does that make the problem harder? Because are robots hard to deal with is a different problem from is continuous control hard? So this is kind of like the essence of the problem. And if these M's can be made High-Perf enough, then we're going to just be able to exhaustively run everything against this, and it will work. Give quick a Chris reply on this, and then start. Parallel. Whatever. Let's go back to this. So the thing I realized is that we need a way to support multiple different policies within each environment or suite, because like Ocean, for instance, Puffer's environments, we want to have different policies for the different environments in there, and conceivably you could want to have different architectures for different environments in other environment suites as well. So what we're going to do, go into Puffer, and we're going to add a this policy here argument. We need to add like a policy name or whatever, policy name. And this is just going to be policy. And we can do this can be RNN name. Oops. None. Or actually, it's just this. And then we're going to have to adjust some annoying configurations in order to make all of this work. But the idea is going to be that we're going to have multiple different policy names specified here. So if I go into, where's it, Ocean, these ones will have the default. But then grid continuous will have our name is recurrent. We'll have policy name is going to be grid. And then instead of having these all named policy, where is it? This one will be policy, the default model. Okay, and then this one will be, this one's snake. And this one is grid. And in order to fix this, hold on, let me check this stream real quick. Cool. Yeah, this works. So in order to fix this, we're going to have to just modify the way that the config loader works a little bit, which is, I hate having to edit this thing. I really do. I wish there were a simpler way to do this, but this is like a multi-stage config loader, and this is as simple as I could get it, and it's still a pain to edit. So we're going to do policy name. And where did they get RNN args? Yeah, so policy name equals config.get policy name none. Well, no, it has to have this. So it's just going to be env. How did we do the override thing before? Env policy. So obnoxious. I'm trying to do like this cascading inherited thing. I don't want to go rewrite the whole config now. I've been tempted to for a while, but then that's going to be like a 5-hour rabbit hole, and I don't want to do that. So for now, we will do Isn't there one that we did this already? Yeah, right. Like this type of a thing. So we're just going to add this as a hack for now. And we'll go from here. So this is going to be policy name. Policy name. Okay. So now we have the policy name. And then we have policy, what is it? Policy class. Class equals getAttr. Policy class. Name. We're actually going to be able to get rid of the use RNN thing, so that's kind of nice. RNN name, RNN class, RNN args. We'll get rid of this use RNN. Oh, wait, shoot. We have to add... Do we have to add stuff here? For use RNN? Yes, we do. All right. Hopefully that's good. Let's just start running stuff and debugging that way. Okay, has no attribute grid. Get adder env module policy name. Dot torch. Okay, invalid argument CNN channels to default. That is reasonable. Did we actually have that in there? That shouldn't be there. Oh, wait, no, because we have... What's policy name? What is policy name? It's grid. Unrelated, but is loss of network plasticity something that has cropped up as an issue? It's hard to say. And it depends what you mean. Yes, there's been some evidence of that in reinforcement learning in general. There's this thing called rerun that I've been wanting to try out for a while now. That's like that some of the... I have this plan that's like make everything fast, make a bunch of good environments, and then be able to run lots of fast experiments to determine stuff like that conclusively, rather than the thing that is happening now where like you run a very small number of experiments and get very weak evidence for something. But there are things like rerun that is something that is potentially cropped up, and it definitely I can tell you one place for sure that it is an issue. Let's say that you have an environment where you have a big action space, and you don't need half of it until later on in the game. Like maybe you can use a bow, right? There's an action space portion that's for a bow, but you don't get a bow until halfway through the game. Well, by the time you get the bow, the model's going to have learned to never take those actions. So that type of a thing is absolutely a problem. More generally, we'll have to wait for the experiments. Check out the rerun paper. Was definitely a good idea to set the multi-streaming on this to YouTube as well, since it seems like folks do actually see it from there as well. So that's cool. Goal for today is to fix up a bunch of the mess that I made with these multiple policies, and then start on getting like actual training done with some of these grid environments. I have a spare puffer box reserved specifically for this purpose today. I have one of them running a 10 billion experiment on a fun environment that I'm working on, and one of them reserved for dev today. So I think it's just oh, that is you, Linky. I thought that was from yesterday. Fair enough. I think the video quality is actually better on YouTube than on X as well, because I'm streaming at 1080p, but X goes only up to 720. But most of my audience is on X, right? Though I guess with the thesis video I did, maybe not so much. I gotta stop starting all these new projects because I have promised a high quality video on Puffer 1.0. I have a really cool idea for a video, and it's just gonna take me like several days to do it. Yeah, I know you were here yesterday. Well, I mean, this will be good for you to have on in the background because you'll get you know, if you're looking for dev stuff, this will absolutely teach you a few things. Linky is one of our contributors on the Pokemon and Red project. He's done awesome over there. I hate this code right here so much. But if the code does not bring you pain, you never go make it better. Where's this make policy function? Wait, why am I returning make? Why am I returning make policy? That makes absolutely no sense. I'm sure that this was like left over from something else, right? This should be what policy? No, I don't need because I have it in config now, right? Yeah, so let's not touch this for now, even though it's stupid, just so I don't break stuff. And then this is going to be... This is args of... I think this is like args of policy class, right? Yeah, and then this is args here. So if args of RNN class is not none... Yeah, there you go. Thanks, Super Maven. Invalid arguments. 102. Right here, this is validate args is going to be end class. Or no, policy class. What is it? Policy class? Yeah. Did I not add this to the args? What do I call this? Policy name. Ooh. So I do actually need to return this. That's obnoxious. Okay. We'll do policy class and RNN class. We'll just say this is going to be env module, policy class, RNN class. And then this will be if policy class. Super Maven will probably get the idea. Yeah. Wait, what? No, it did not get this whatsoever, did it? That just was bad. So we do policy is equal to policy class. Like this. If RNN class is not none, then we make it an RNN. Else. Yeah, there we go. This is what we want. And we do not need env module here anymore, right? Don't need env module. So we do, let's go get the signature for load config. Policy class, RNN class. And then I guess all this junk has to go into train, right? Make env policy class and RNN class. I really hate this demo file. Everybody hates this demo file, to be fair. But so far, nobody has given me a better way to do this file. I've tried very hard to make this file reasonable. Just nobody's come up with a good way of doing it. Env policy class, RNN class, args. Policy class. So you're going to be very disappointed by my Vim config. That's such a bait question. Oh my gosh. It is on here, I think, right? Yeah. So I think that I just forgot to change. Oh no, yeah, this is updated. I used Vim with no plugins, nothing, for like 6 years. Now I have 2 plugins. I have Super Maven, and I have Semshi for some extra syntax highlights. I don't really have any extra commands or anything on here. And then all of this is just my the color scheme that I made for this. That's literally it. And as it turns out, we actually fixed training while I was talking about that. But yeah, Puffer Tank comes with my Vim config and NeoVim setup in it just because convenient. Okay, so this is nice that this actually trains. Let's make sure eval works. Does this work? Make policy. No, because it needs the policy class and RNN class, right? So args.n policy class. I've always thought you're kind of missing the point if you spend a whole bunch of time like hyper fixating on like making a very complicated editor config or like system setup or something. On the flip side, you know, buying a Mac and just using it with the defaults is also probably just not giving enough fucks. Class. Yeah, there we go. I want to make sure that eval and train work. How's it missing 2 keyword args? Or positional args? I just added them. Oh, because I added it to this stupid Pokemon function that shouldn't even be here. Do we still need this in here, Linky? Is there still like a custom rollout thing, or is there some way that I can get this out of the main file? Sick of having like custom environment stuff in the demo file. I'm really tempted to just like remove it. Okay. I'm really tempted to just give you guys because like you guys hate the demo file too, I know. Like why don't we just give you guys like a simple demo script, like one of these? This one's designed to be edited. You know, the real demo script isn't designed to be edited as often. This one is like you hard code whatever single environment you want into it. It's like 100 lines shorter. It doesn't use the configs, something like that. Oh, well, that would make sense. Love deleting code that is not required. Module. make policy. Got unexpected. M policy class R and N class args, right? Well, this isn't supposed to be star args. This is just supposed to be args, isn't it? Like this. Dict object has no attribute policy. What? Does this actually make any sense whatsoever? Stop policy. End module args. You just need this. This actually gets simpler. Very nice. It is a good day when your code works and chocolate chip cookies are a legitimate part of your diet. I think we can commit this to dev, right? Let me make sure I didn't break snake, because there are actually people using... I know there are people who actually want to use the snake env. Yeah, let's just fix the snake env. Everything else can be broken. In dev for now, I don't care. But the snake env needs to be working. Well, that works. Here's your snake env. You can play it. It's very nice. It's actually kind of fun. Make sure train works. Joined a little late. What are you up to now? What did you decide to do for the continuous control engine? Discretization? Yes. I'm literally just about to do that stuff. So, it ended up being way simpler than I thought. Literally all you have to do is discretize the state into a grid for the purpose of computing observations. That's all you have to do. And then you have an identical environment for discrete and continuous action spaces. We're actually about to talk about that. Let me commit all this stuff up, and then we're going to go through some stuff. PufferL, config, demo. PufferLib, environments. Is Ocean meant to be overly simplified environments that can be all trained side by side? Wondering if it can be used for a generalized training approach as an entrance to curriculum learning, or would neural MMO be better? Ocean is just, that's what it started as, but Ocean is now just the blanket repo for, or the blanket term for PufferLib's first party environments. So anything that I have made or I have, personally done for PufferLib. The classic Ocean tasks, which we're going to have to like find some sub package name for or whatever, are probe tasks that are designed to test very specific deficiencies in implementations. They're meant as quick sanity checks. They train in 10 seconds. The snake environment and neural MMO and like other things that are going to be in Ocean are, well, they're pretty much anything that I've done for it. The general themes are ultra high performance simulation, variety of different complexities, often massively multi-agent because that's my main jam, but not necessarily. Yeah. It doesn't really derail me much. I like, actually kind of keeps me on track when I go interact with the chat. Let me commit all this stuff up. Welcome, Red Eye. I've always done my commits manually like this, just because I want to know exactly what I am messing with. Like in here, I can see that there is star.py, x, png, and that's all I need. I'm just committing up some files. You're gonna see, I have a cool segment coming up just in a second here. Let me just push this. Latest dev, messy, breaks some envs, snake works. Okay, so now what we're gonna do is I'm gonna go back to the continuous control engine. I'm gonna talk about what I want to do with it. We're gonna decide on some tasks to implement. Hopefully that's gonna be easier than yesterday since I'm fresh, relatively. So, yeah. The guy doing everything in Vim is not using Git Desktop. I'm stubborn. So, we had this original environment that's discrete, a discrete environment that supports multi-agent particles. Like every environment is, every agent is a particle. It can move around. You can instruct them to do different things via the reward signal. There is a little bit of infrastructure behind doing this incredibly quickly, so it simulates multiple millions of steps per second. The general idea is that you can either just simulate a 3D grid, and then every property you need of an environment can live on a 3D grid, or if you want to be a little fancier and a little bit more efficient, you just store a grid of player IDs where each ID is an integer that tells you what agent it controls, and then you use this to index into a struct, essentially, of different players. So, element 0 is player 1, and it has various different properties, etc., etc. Fairly simple. You don't really need this because this environment is so simple, but whatever. I wanted to then make this environment continuous. So I thought about different ways to do this, and I came to the conclusion that it's actually really easy. And all you have to do is you allow the agents to move a continuous non-integer value, so they can move however much they want. You store their position as a float, But then when you write to the observations, you discretize to whatever the resolution is of the image. So you have continuous actions, continuous movement. You could even do acceleration and stuff like that if you want to, though I didn't add that yet. But you get the same exact observation space. So this produces tasks that are one-to-one the same between the continuous and the discrete case, which means that if we have several of these tasks that are kind of reasonable, and we can train discrete agents, we can train continuous agents, we can see whether our continuous learning setup works as well as our discrete learning setup, which will be a huge boon to continuous control people that have problems with janky algorithms, as well as being a very nice test case, a way to show that Puffer is provably working on these types of environments as well. I started this doc where we started looking at different tasks. I think some of these are good, some of these are not so good. So these two are classic problems that have been used for a long time in multi-agent. Sometimes they're posed in weird ways, but I think some variation of foraging where you have to spread out and eat food, and some version of predator-prey where you want some agents to chase others, these are good. This one was a little bit more questionable. I'll think about it. Grouping up, so you have several different types of agents that have to group up with their own groups and stay away from other groups. That is slightly different from the predator-prey one. This one is purely cooperative. It's kind of interesting in that sense. And then I felt like doing a promo task in which the agents have to assemble to spell out the words PufferLib. I thought that would be fun, and it's a decent little test case as well. So that's 4 tasks. I don't know. Let me think if I want to do this optimized task, how I would do it. It might not be that hard. If I make the food continuous rather than discrete, the food is just a continuous amount, that would work. Jungle Basketball from Eric Jang. Nope. Robotics guy? Oh, this one. Oh, yeah, the Olympics. I saw this thing yesterday. This thing here, right? Is this guy's work, or is this just something he's reposting, though? Because I saw this online. Yeah, it's cool. We could potentially add a binding for it. Do they tell you how fast it is? People really got to say how fast stuff is. Initial code release, code trainable, repo under construction. So we'll give this a little bit of time to cook. If it's basically, I'm going to add bindings for anything that is reasonable enough to work with and is fast. Let's see. This is not true. Okay, whatever, Chris. Let's go look at this. Welcome. I can't quite see the name. Yaniro, if I'm pronouncing that. Welcome. Let's get into some actual dev instead of just freaking scrolling Twitter endlessly. The thing with Chris is somewhat annoying because like Chris is somebody who I respect a lot and does very good work. I disagree with him on Jax, but I think he's mostly just mad that the article was written in a sort of inflammatory way. I held back a lot on the way that I would post stuff during my PhD because I didn't want it to reflect badly on my lab or on MIT or stuff. But the state of RL is just pathetic. We need to fix it. It needs to be fixed now. It's not that hard. Just do it. What we're working on today is a continuous control engine for a bunch of simple tasks that can be done obviously continuously, but also discrete. This is going to be a very nice way of seeing whether or not continuous optimization losses are as good as discrete ones, or whether they're like fundamentally different and one is harder to tune than the other. This will be very useful for continuous control people, and it will be very useful as a test case in Puffer, as well as for other people who want to use Puffer on this stuff, because these environments should be trainable within a few minutes at most, and will run at millions of steps per second. That is what we are currently building. So let me think where I'm going to get started here. I think we can start locally. We can start with this list of tasks. We're going to have to add... The only two features that I have to add to this environment to make this work are there needs to be a layer for food, ability for them to see food, and there has to be the ability for the individual agents to have different colors associated with them. So let's look at that. That's going to be slightly awkward because one of those values is potentially continuous and the other is discrete, right? Maybe not. Starting from more RL people that are major problems with the field, starting from more RL people that there are major problems in the field, why do you also say it's pathetic? I say it's pathetic because if this were like, yeah, the problems are just really hard and, you know, we've done a good job, then I would not be able to like sit down, write a few hundred lines of code and solve something that's been unsolved for 10 years, which has been happening like regularly over the last couple of months. Academia heavily disincentivizes core infrastructure work that is required for the field to actually function. Heavily disincentivizes core infrastructure work, so just nobody's done it. So everybody works with really slow, janky environments, doesn't have like proper ways to tune baselines. It's work that I'm not going to say it's necessarily simple, but it is absolutely something that can be done at the scale of a single individual and has never been done. Like this little continuous control environment. I mean, this seems like a really basic question to ask, right? Hey, if we swap the action space from discrete to continuous, does the problem fundamentally change? I've never seen anybody ask that, and I've certainly never seen anybody like do a comprehensive evaluation of that like we're doing right here. This is like something that is going to be I mean, I'd be shocked if this takes me more than a few days to complete fully. If it does take me more than a few days to complete fully, it will be because continuous control is jank. That's another way of putting it. So right now, I have the grid as a uint 8. If I want to add continuous amounts of food, I'm not going to be able to have it be a uint 8. I'd have to make the observations continuous, or the food layer at least continuous. This would be bad. Yeah, the academic environments are... I've done more in the last 2 months than I've done in the last 2 years. And that's with a good lab. Like, it's just the publishing cycle is a mess. Yeah. So I can't do, if I just add the, so this would be basically the same as the snake environment. If I just add a few different agent colors to this, that would support this group up task. I could support the PufferLib task. I could support predator. Can I do predator prey with that? Yeah, I can do predator prey with that. I could do foraging with that as well. I just have to add food as a channel. The only one I wouldn't be able to do is this optimize task, which, you know, we really don't need that. I think I'm good with there being 4 tasks because they have to be optimized, continuous, and discrete. So having 8 different environments, essentially 8 different things to test, that's a nice start. And these are, yeah, these are pretty nice. So let's just add that. So we're going to do, wall will be here. Wall will be 1, agent will be. We need to choose some colors. So what did I do for snake? I did red, white, and blue for snake, didn't I? I think I didn't just copy that. That'd be funny. We just make all the environments America themed. Since I did the snake one on 4th of July and already have the color codes. Yeah, there we go. It's reds, whites, and blues. Okay. And did I have the... I think I just called them like Agent 1, Agent 2, Agent 3, right? 1, Agent here. Agent 2, 3, Agent 4. We also need food. USA. Alright, that's 7 different things. Playing around with generalization experiments in SB3. Had to expose a lot of core SB3 code to fit my use cases. Not to bash on it, but it does feel janky. Yeah, and SB3 is one of the better ones as well. But the design philosophy is just fundamentally different. So the way I approach stuff with Puffer is I assume everything is white box software. Which means that you're going to have to edit every part of the software at some point because you're going to be doing some crazy thing that I can't anticipate. Like reinforcement learning is not a mature space, right? This is all research. So what I do is instead of trying to like box up all these components so that they snap together like Legos, I just make the code as simple and as short as possible so that it's easy for you to onboard and edit. That's how I write stuff here. If it doesn't have RK4, it's not continuous control. The action space is continuous. If the implementation works well with continuous action spaces, then the problem of whether this specific robot end is hard or not is going to be separate from whether or not continuous control is hard. That's the idea. What time is it? 12:49? I think I have a 4 p.m. call, so I'm good for 3 hours. I have 3 hours in me. Okay, so we need to add food. Fundamentally, we need to add food to this environment. How are we going to... Well, the agents aren't going to die if they don't get food, right? It's just going to be a reward for food. So I can just add, like, food reward, right? So reward function introverts, and I can just add food reward as well as an extra thing, right? Food reward equals 0.1. Okay. Oh, and then there's this other trick that I like to do where I think I did this with Snake, right? Didn't I do this thing with Snake where... No, I think it's fine as is. Never mind. I thought something was applicable and it isn't. Okay, so we add self.food reward. Oh yeah, this is where I was going to do it. So the trick here is instead of doing like equal agent 1 or equal agent 2 or equal agent 3, we just do greater than equal to agent 1. That was the trick. Because you define the indices like that. Self.food reward. Okay, and now we go into... I'm going to actually just go over to here. It's going to be easier. Float. No, not... Add food reward here. Ob size, agent speed, load food reward. Okay. Now what we do is we add... Unfortunately, we do have to duplicate the enums here, which is slightly annoying. So we're going to put these here. Okay. And now it's very easy, I think, for us to just... Yeah, it should be very easy for us here. I'm actually tempted to move this into Python, but it's okay. Where's the move function? Okay, so if this is supposed to be empty, not food. Gotta be careful with the hard-coded indices. So if it's food, then what we do is we set it to empty for a second, and then we do self.rewards. It's gonna be food reward. Does this thing have rewards? No, it doesn't have rewards. So we need to add the reward function into here, which is somewhat annoying, but not too bad. Agent positions, observations, and we do rewards. Where's the observations? Float rewards. Float array. And rewards is equal to rewards. Good. Pass this after observations. Where is it? self.buff.rewards right here. So what the reason for this is that if we pass this array, it's the same trick we're doing with observations. If we pass this as a buffer into the C environment, then we have access to mem-shared data from both Python and from C. So we have very, very fast ability to update rewards and to read rewards from Python and from C. So this is now done. And now I have to change the way that rewards are applied for sure. So the way to do that is you just have to add the reward function to the buffer. So these come from C, these come from Python. Oh, wait, can you even do this like that? No, wait, you can't. There's no point in doing the fill operation from Python because it's a NumPy operation anyways. So it's just going to call back to Python to do that anyways. So let's just do, right here, we'll just do self.fill 0. Good. Okay, so this is now reasonable. Where's the renderer? Yeesh, this is the renderer here. I kind of want to one-file this whole thing. Was this where it was? Wait. Am I... Yeah, it's... Let's just take all this code. 100 lines. We're just going to put it in this file. Okay, now we got 300 lines total for the environment with no additional stuff floating around. Now we can just have, this is just make render. And we'll apply some of the cleanup from the snake env in a bit here. But as for the asset map, we kind of want this snake one here, don't we? Didn't we actually make like a way better renderer here as well? I think we want the snake grid renderer. Yeah, because this is the entire snake renderer right here. So we don't need this grid render thing at all. It's just a waste. Make render. So this make renderer thing is a total waste as well. So let's just update that. Oops, where is it? So if render mode is human, self.client be equal to this. Asset map with height. I think we just do this. Yeah. Because we're not going to use this mode for a bit anyways. So self.render mode RGB array. Then we can do frame equal colors. Grid. And actually, we can cut the... Oh, this is... Well... Let's do vision. Where is it? Vision. Self.vision range. Grid of... Self. Grid? No. Grid equals self.grid. Yeah, and we'll just leave like this for now. And now we just go get colors from snake. Grab all these. I could make the ASCII renderer for this as well. You know, this is... The snake render is kind of good. I might just use something similar to that, and then I might end up making like just a uniform render for, you know, all these different little projects of mine. But for now, it makes more sense to just one file stuff and just see if it's actually the same code or not. Yeah, so this is fine. Turn frame. What did I do here? $11 positional args. Did I like forget to pass something? Wait. Ah. C grid continuous. What's the signature here? Grid agent position, spawn position, cans, observations, rewards, width, height, number agents, horizon vision, speed, discretize, food reward. This is correct. Oh, did I just not... I didn't compile it, right? That's fine. And agent... I'm going to do agent 1 for now, like this. And we will edit this in a little bit to support different colors. Right, we have to edit the torch model just a little bit, because this now takes a few additional channels. I believe 7 additional channels. And is this still 3? You know, this is still 3. Cool. I think we're set here. We'll see if there are any little additional errors. Expected to have 3 channels. Oh, right. The observation space we also have to update so that it correctly reflects the... No? Wait, this is fine. Space. Yeah, no, this is totally fine. What is wrong here? Given weights of size 3. Didn't I just edit this? Did I edit the wrong one or something? CNN channels. Oh. This was 3, right? What was this? Yeah, this was 5 up here. This is the kernel size. This is the one that has to be 7. Puffer grid has no attribute rewards. This is self.buff.rewards. Okay, cool. So this now runs, and we have our nice puffer env. Now we can make this have different agent colors or whatever, and we can add food, and we can do all sorts of nice things. I think we're going to start by... We're going to have to add an argument. We're going to have to add, like, agent colors or something, right? To the args of the init. Yeah, that would be the easiest, right? We just add, like... Let's do it that way for now. I have some ideas on how we can make this a slightly more general and useful thing in a bit. But for now, let's just do, like... self.agent colors, p.random.randint, and it's going to be from 3 to 6, so was that what 0 to 4 plus 3 or whatever? But we can just do 3 through 7 agents. And we will pass this to the C environment, maybe? Does that make sense to pass this to the C environment? I don't know. I can't really think all that well today. Let's just do it the dumb way for now, and then we'll fix it if it needs to be fixed. Spawn position cans. Agent colors. Agent colors. C grid continuous. Agent colors. And we'll do float agent, no, into agent colors, right? Into agent colors. Did I give this thing a D type before? Nah, it's probably an int. And we'll do self.agent colors. Assign that. And now when we spawn the agents, right, when we spawn the agents, this is the agent spawn code right here. Instead of being agent 1, this is going to be self.agent colors of agent IDX. Now this is also going to be self.agent colors of agent IDX. Okay. Let's see if that does, oops, well, we forgot to compile it, so that's not going to help. And if I've done this correctly, we should get various different colored agents. Expected int got long. Okay, that I was somewhat suspicious of that. D-type int 32. Hey, very nice. So we've got red and white agents here. And we will go make some blue food to add to this, right? And then this will be set. So let's do is food indexed 2. Let's actually make the wall 2 and food 1. 1 second, and you'll see why. It's just going to make it slightly easier. It's going to be slightly easier to do numpy.random.randint 0, 2. And that would give us food. Not seeing the food. Should be blue. Oh, it's because of this grid fill. Okay. We'll just do like this. We'll just remake the... Oh, no, we can't do that. You have to fill it. So, here, self.grid. Cool. So we make it zeros, and then we fill it here. So self.grid, star. You can copy stuff into the grid. That's acceptable. Kind of slow. We might find some other way of doing it. Self.height, self.width. Okay. There we go. So now, are they eating the food? Yeah, right? Like whenever they walk on the food, it disappears, yeah? Awesome. So this is our basic environment that is going to be required to implement whatever we want. We need a few things from here. We need to implement the tasks, and we would like to have a clean way of implementing tasks on top of this grid type environment. That is what we would like to have. I think that in order to do that, It's actually a fair number of things you need in order to do that. You need a reward function. I guess a task consists of an environment initialization and a reward function, right? Yeah. Environment initialization and a reward function. Let me think how I want to do that. Really don't want to make a bunch of subclasses of this environment. I could give it the functions to call, I could give it an init function to call, and I could give it a reward function. That's kind of how we have it at the moment. That wouldn't be bad, right? Man, it's like I'm so used to just subclassing stuff and making a mess of things in the long run. I have to like get my head out of that space. We're just gonna do it how we're gonna do it for now. So we're going to take a, we're going to just define some reward functions. So we're going to move these outside, up top maybe. Takes observations. I think this is just env, right? You have full access to the env. Okay. And we need to make some init functions, right? So this is going to take reward function, init function, reward function, right? And instead of doing string, we can just make this the reward introverts function, right? Init introverts, like so. And then it's just going to be self dot init function, reward function. That's actually kind of clean. That's really not that bad. So we make an init function for introverts. Now, the init function should take care of spawning and the placement of any obstacles or food or whatever, right? So these spawn position cans, we'll leave them like this for now, but they're probably going to have to change. I don't think we have to do anything for this specific env. We call this inside of reset. Self.init function. And we call this here. And yeah, So this would be inside of like the reward food one or whatever. Init foraging. Okay, let's see how this does. Still work? Yeah. No? Self.reward function, yeah. One little change. Okay, so now we have this particle env. We can define tasks in it. We're going to have to come up with some slightly cleaner ways of doing that, but I can sort of think about that over time. Let's get all of the tasks that we are interested in implemented, at the very least. Let's get all of the tasks implemented. So we would like to do the foraging task. So we have init foraging, which is you make some food. And this is kind of too much food, isn't it? I think what you do is you do like RNG equal numpy random.rand of env.height, height, and .width, and then you do env.grid of RNG less than prob food prob 0.1. Food prob is food, and then otherwise it's empty. Reward foraging. What do you have to return? You don't really have to return anything, right? So this is inefficient, but I'm going to return just zeros for now. Okay, so we have the foraging spec here. We actually kind of want to do the agent colors in here as well, don't we? You do want to put the agent colors in here. But I can do it inside of, because it's memory shared, I can do it inside here. So I can do, it's fine for this one, for them to all be just random, right? Predator. Prey. I think we're not going to mix it. We're not going to make like the predators also, the prey also have to get food. We're just going to do a pure stay away from other agents task. So how do I have the color set up? This is from Snake, right? So I have red, white, red. So yeah. Agents. So let's do env.agent colors. So over 4. Star n is going to be agent 1. And this is going to be agent 3, which is going to be predators. And well, should I just use the first 2 colors? Maybe I should just use the first 2 colors. First 2 colors are bright red and bright white. Yeah, that's fine. We'll just use the first 2 colors. So this is going to be agent 1, and then this is agent 2. And what else do we have to do to initialize these? We're probably going to have to like move them apart or something, but we'll handle the spawn position differences in a little bit. I think that's all we have to do for init is just make sure that they are defined this way. Reward, predator, prey. Reward is going to be zeros. And then reward introverts here, right? So n is going to be num agents over 2. And then we do rewards of so the prey reward is going to be it stay away from the predator specifically. So this is the predator agent here. We're going to still clip the rewards, I think, just like before. And we need the predator reward, right? Which is going to be this doesn't need to be 1 minus anymore because the current agent is not included. So this is just going to be positive, right? Yes. So predator wants to keep prey in sight. Prey wants to keep predator out of sight. And that's the reward for predator prey. Optimize is not happening for now. Group up is going to be simpler, I think. Init group. We're going to do, I think the default just like randomly assigning agent colors is actually good here, right? Yeah. So the reward actually should be very easy. Did you define insight? Is it just a check of surrounding area? Yeah, so the observations here, this is a 11 by 11 window that is centered on the agent. So by checking just the local window of observations, right, you can sum over that window. So this is comparing the window, all of the stuff in that window to the specific agent type. And then we can see how many agents of that type are in the window. The init group one is going to be very similar. It's going to be even a little easier. So it's going to be rewards equal, nope, not zeros. It's going to be it's going to be like same equal to what, this thing here, m.buff.observations equal to, we need the agent types, don't we? Self.agent colors. Is that going to be, well, we might have to broadcast colors, m.agent colors. So you get rewarded based on the number that you can see of your own. This you have to subtract 1 because you can always see yourself. And diff reward is going to be 1. It's going to be negative of this. So you get rewarded 1 for each agent that you can see of your same population. You get penalized for each agent that is in a different population. Then you return. So rewards is going to be equal to same plus diff. And actually, we can get rid of this negative and we can just put minus here. And we can just clip it. This is not supposed to be the init. This should be reward group. And then init group is actually just going to be a pass. Don't need to do anything. And then the PufferLib task is going to be a little harder because I'm going to have to go and figure out how to get a bitmap of PufferLib, maybe even the Puffer logo. We'll see. We're going to have to get a bitmap of that and see if they will match it. So maybe we can even start trying these out already. Easiest one of these is going to be foraging. This env is partially observed. How will agents complete puffer task if the logo is bigger than their window? So yes, the env is partially observed. The starting positions are going to be appropriate for the task. So for the PufferLib task, I'm going to spread out leading key. This is right before I started this, I committed some version of this to dev. You can look at it. Yeah, I'm trying to make it easier to add tasks at the moment. JBL, yeah, so for the puffer task, for instance, I'm just going to start all the agents at the top of the map in like a blob type thing that covers the top of the map. And the hope is that they're going to learn to just cascade downward, and then they'll just sort of fill in pixels based on where they're getting reward. You know, the task has to make sense. If it's partially observed and there's no way to get there, then they're not going to be able to do it. But like the predator-prey ones make sense, partially observed. The foraging ones make sense, partially observed, though you're going to have to learn to explore a little bit, right? Everything else sort of makes sense. The reward for groups may be that you won't get one group for each agent type, right? Maybe they'll split into multiple groups, so they won't get like as much reward as they could, but it should still be able to learn something very reasonable that we should be able to evaluate. And it's very important with these types of M's to get the reward on a scale that makes sense. So hopefully we're going to scale stuff so that like the maximum reward or whatever is going to be like 1, and the minimum will be 0 or something like that, or -1, whatever, across all the different environments. So we're going to have very nice, easy to evaluate metrics on all of this stuff. Let's do foraging, init foraging. First, does the eval make sense? Yeah, eval makes sense. Is this 10%? Seems like a lot of food. Whatever, should be very easy to learn, right? So let's do mode train -- multi-pros. And let me make sure I have a reasonable config. Grid. Yeah, so I have a reasonable configuration here. just see if this does anything remotely reasonable. I think it was being a little bit obnoxious yesterday. It is a little bit annoying that this does not give you rewards back consistently. I'm going to go ahead and fix that. Oh, interesting that I made it episode rewards. Tick percent. We'll do like this. We get any rewards here? Yeah, so this is obnoxious that this doesn't work the way I'd like it to. So let's just redo this experiment. And this should give us something a little bit more reasonable. Pretty much same network as Snake. Still not seeing stuff showing up in user stats, which is weird. I did commit this, right? I mean, I did, yeah. Episode return. Did I just mess this up? If tick percent 32. Oh, am I not increasing self.tick? No, I am. So maybe it shows up in here. Very weird. It's a little bit weird how this thing logs. Episode return. Yeah, it's a little weird how this thing logs. I'll have to mess with that. How did I do it in Snake that it worked? I was just running it at much larger scale. This is 0 regardless. Because that's not helpful. Yeah, so here there's a special case to see if episode return is in here. So it prioritizes logging data that has episode return in it. But I didn't do that for Snake and it still worked. How did I do it? So for Snake, I did every 128 steps, which is not very often, and it still worked. So is something off here? I didn't do episode return here. Oh, right here, this else. So what we're going to do is we're going to just put this down here. Yeah, that'll do it. Now we'll be able to see. Cool. So let's see if this is actually 0 or if there's a slight positive reward here. Uh-oh. I'm gonna have to delete some runs apparently. Should be okay for a little bit. Okay, the reward is actually 0. Which leads me to believe that we're just, like, not updating it correctly. So where's the reward for food? Okay, so this is 0 reward for food. But you should be getting a reward based on food eaten from the environment itself, provided that we've passed the rewards correctly. Which, where did we do that? Yes, so we passed buff rewards here. And we fill it with zeros here, but then we step it, right? Continuous. Food reward. This looks reasonable. Food is 1, wall is 2, right? Food is 1, wall is 2. Did I just forget to recompile it, like, since I last changed that? Looks like it's building something new, so something changed. And we should hopefully get something that is not 0. Really? Welcome back, Samurai. We are currently fixing this environment up so that it will actually train some cool tasks. Hey, curious if you faced any limitations with Scython. If you've answered this, apologies. Scython is absolutely amazing. Like, it is so freaking good. Scython has single-handedly fixed, like, most of the problems that I have had, limitations that I've had in the field, because you can give it to researchers. It looks like Python. It is Python with a couple types added. It's super fast to write, and you can get C native speeds. And you can get shared data access between Python and Python, read and write, shared access very, very easily. So many good things. I've had like a couple very small nitpicks with it, but so far it's like, use Python. It's amazing. Love me some Python. The few nitpicks would be they kept the C behavior of passing structs by value, so you have to use pointers, where if they just passed by reference, you wouldn't. I wish they would have kept that from Python. You cannot define variables inside of conditionals and loops. You have to define them at the top. That's slightly annoying. And the compile times could be better. Those are my main annoyances. Okay, so seriously, what is wrong with this food thing? I think we need to just go put a print somewhere in here. Oh yeah, and you can't run PDB inside of Python. I really wish you could run PDB inside of Python and like debug at the Python level. I know that would be slow, but maybe you would be able to do it. Food. Yeah, Python is like keys to the kingdom for high performance simulation engineering without spending months having to do it. It's like I can build stuff so fast now and actually have it be High-Perf. In fact, it can actually be faster to build in Python because I can write the code really stupid. You know, I don't have to spend time doing like optimization crap that I would in Python. Like I just do it in Python and it's fast. It's so nice. Love me Python. Okay, so right here, this should be something. That was a lot of food prints. That was like a lot of food prints, but okay, so it says that we're getting rewards, but I'm not seeing any, which is very weird. My guess would be that we accidentally assigned rewards somehow. Did we overwrite rewards somewhere? I have a fill here. The fill should be fine. I don't know why this rewards is not synced. Self.rewards equals rewards. Self.rewards of agent IDX. This looks fine to me. Is it the fill? I don't think that the fill would do it, right? Oops. Rewards. Did I do like env.rewards equals or something? No, this returns zeros. I do like this. Maybe the plus equals is not in place as I think it is. Really? It's occurring to me that I'm not seeing it actually getting food here. It should be getting some food. So, what is up with that? Init function. Oh, is it deleting all the agents? Let me see. Yeah. So it needs to be like times env dot grid grid D. I think I was overwriting the agents. right? Thoughts on Jax? Is this a troll? I literally wrote like a super ranty post about this. I mean, this article, I literally wrote like this stupid rant article that blew up. Here, this thing has 140,000 views on it on my relatively small Twitter. Not a Jax fan. Main reason for it is the problems that it's solving are way more easy to solve directly with relatively basic infrastructure, and the price of Jax is introducing a domain-specific language to everything. So, especially for environment simulations, I can write dead simple code and have stuff run at millions of steps per second, or I can be forced to implement stuff in a domain-specific language and now be heavily constrained in the types of environments I can implement in the first place. A lot of people do like Jax. But wait, do you like it for training or do you like it for environments? These are two different things. I don't really like it for either. I'm slightly more tolerant of it for training than for environments in most cases, though there are some environments, some like niche cases where it makes a lot of sense for environments. But I think it's definitely being overused right now. Heavily, heavily overused, and it's causing RL a lot of problems. Mostly for OD. Yeah, that's totally fine. If you're using it for like scientific computing stuff and you just want like an easy way to do array ops on GPU, that's totally fine. The problem is people are trying to implement full stacks where the environment, which is a complex simulator, is end-to-end JAX. The reinforcement learning library is end-to-end JAX with tons of third-party poorly developed libraries like Flax, which are like god-awful hybrid of overly functional and overly object-oriented programming. And the whole stack essentially grinds to a halt because they've introduced all this complexity in the name of performance instead of just like not writing stuff in plain Python. Like domain specific language inside of Python versus add a couple types in just Python. Like I don't understand how this is a comparison, right? Totally fine for other applications. The post was for RL infrastructure specifically. Can I do ampersand here? Really? What about plus? What's the Boolean mask op in isn't there a Boolean mask op in NumPy that just works? Or do I really have to do like this times like dot bool? Was it dot as type bool? Truth value of an array with. Am I doing this wrong? What? Huh? Oh, is it the parentheses? It's the parentheses, right? That's so obnoxious. Oops. I would have thought that the, I guess it makes sense why that happens, right? If you think about it. Yeah, of course. It's going to bind. It binds those operators last. Okay, something is really jank here, and I don't know what it is. Can I just, like, eval this? Yes, I've spoken with Alexi quite a bit. So Sample Factory gives you very good performance. The code is much more complicated than something like Puffer. So I am trying to get as close to that level of performance as possible. Actually, in some cases, I think I have better. But he has a lot of optimizations that I don't. But I'm not willing to complicate the code bases. I want reinforcement learning to be like dead simple and performant by default. That's the whole thing that I'm going for. Like clean RL simplicity, sample factory performance, if you want to look at it that way. That is the objective. Clean RL simplicity, sample factory performance. And actually, sample factory performance only takes into account the learning library. I'm also re-engineering the environments themselves to be 1,000 times faster. So, like, together, you can get stuff that is way, way, way faster than Sample Factory is now because you're training on, like, equally complex environments to what you'd be using anyways, but the environments just run way faster. Like, the Snake environment runs at 14 million steps per second on one core and trains at 1 million. Linky, it makes the RL more accessible to everybody. Like, PhD researchers don't understand what the hell's going on in this space either. It's just all a mess. It's not like, oh, you need to take the time to learn it. It's just everything is freaking hard and a mess. Sample Factory is good, though. Sample Factory is very, very good. I mean, the main objective of Puffer is not to make RL easier for beginners. The main objective of Puffer is to push the boundaries of what RL can do. But the thing is that I think that the best way to do that is also to make it simple, which happens to have this nice side effect of making like a lot more people able to get into RL easily. But yeah, like a good thing to do is like with Sample Factory, it's just like open up the source code for Sample Factory, try to figure out where all the components that you would expect are, open up the code for Puffer, see where all the components are, and see which one is easier to figure out. Right? Puffer doesn't have all the stuff that Sample Factory does, though. The lean key, you're rapidly running out of noob credits. You know, after it's been a year, you're gonna just be expected to know things. That's how it works, right? uh, what is going on here? This is so weird. Is it this thing? Something's wonk. Okay. So the rewards are just not coming through, and I don't get why not. Buffed up rewards. It's here. Gets assigned. Oh, let's put this like this, maybe. Interesting. So when you do that fill, does that like screw something up? Wait. Did I mess up? Where is food reward? Did I put it in the wrong spot? Oh man, I put this on the spawn. Oof. That was stupid. That was very, very stupid. It's supposed to be there. My bad. One of the side effects of starting your day with 2 to 3 hours of hard exercise is that occasionally your brain will just decide, no, I'm not going to work today. Are these eating food? They're moving around the food, aren't they? Wait, if disk... This is dest y, it needs to be here, right? Disk, dest x, yeah. I have the names wrong here. Cool. Yeah, I thought that was a pretty good line. I'm sure that's gonna piss off a lot of people. I swear, like, heavy functional programming is just like computer science's world of like intellectual navel gazing. It's just what the hell. Heavily functional, heavily OOP are just both insane. And like trying to like, oh yeah, well, we're gonna make a functional library. And the crazy thing about it is like, I'll post like some absolute garbage snippet of code that's like makes no sense. And then I'll have like 3 or 4 people online telling me, well, it avoids side effects and you avoid bugs because it's declarative or whatever. And it's just like, look at the code, it's garbage. Like, I don't, literally, it's just doing random stuff that's not even written there. What on earth? Okay, that's good. This is work. This is working now. There we go. These things get reward, they eat food. I think that there was something weird happening in reset, so we're just going to watch this for a second until it resets and does the weird thing. Yep. Okay. We do self.grid.fill. And hopefully this is now good. You know, the sad thing about that Jax rant is, like, I get mad because I waste an hour and a half on stupid Jax things, and I'm like, this is not the way forward. So I write this really low effort post, right? And then the next day, I write an actually good post. And everybody gets mad as well. Everybody's mad about this stupid post. And then the next day, I write a good post, which is like actual infra teardown of the puffer cluster that has a lot of really cool information in it. And it gets less than a tenth of the... Well, actually, no, this is 100th. This is like 100th of the exposure. So, I don't know. Interesting. We actually got some cool replies on this, so... Search space. I don't buy this. I don't buy this take. This is sometimes true. Small, just, yeah. Maybe, yeah. Is this, yeah, okay, this is the Sony AI guy. Cool. Ooh. Very nice. This is old, but, what? Oh. That's nothing. Alright, let's see. Yeah, this is now correct. There's no, like, old artifacting here. Let's train. Leave a trainer on it for a couple seconds. Let me read chat. Been super bullish on Jax, realizing how much effort I put into hackily massaging things just to get them jittable or back. Yes. So that is the problem with Jax. And if you don't know that you need GPU and you just need things to be not Python, try Python. It's awesome. What if you could just write loops and conditionals in like arbitrary code and just have it be C speed, but not actually have to do C things and, like, you know, not like get actual reasonable error messages when you go to compile stuff or when runtime stuff happens. I think it's really, really nice for that. It also has very nice integration with NumPy. So if you're doing scientific computing stuff and you need to do like slice operations over arrays, that can be done very efficiently. Mm-mm. But yeah, the thing that you described, that is the precise problem with Jax. Now, mind you, it's a little different in my case, right? Because we actually are doing something with the GPU. Like, we'd like to use the GPU for simulating neural networks, not for simulating the environment. So with Puffer, I have the cores spinning at 100 doing the environment, and then the GPU spinning at, 100 doing the neural net. So there's a efficiency there. And this is actually already training. This is already optimizing into peers. Doesn't look like it's necessarily performing great, but it's better than nothing, maybe. Is this continuous mode or discrete mode? I forgot what I left it on. This is discrete mode. Okay, not amazing. Do we get episode return, though? Ooh, episode return went up and then it goes back down. That could just be hyperparameters, though. Let's get the other tasks to appear to be working, and do a few more things from there. Yeah, so this crashed. Mm-hmm. Other environments. I don't know why I'm so tired today. Holy. I've got 2 evening meetings, so that's chill at least. Reward. Where'd the dock go? We have the dock somewhere. Yeah. Foraging, predator prey, optimize group. Okay. So that was foraging. Where'd it go? Predator prey. We'll see how this does. If this makes any sense whatsoever. Oops. Slice indices must be integers. Probably should have, before I tried to track the run, I should have just done train like this. This one as well. Oh, did it not post the stream? Maybe it didn't post the stream on X. I'm trying to figure out why, like, I was doing the same stuff yesterday and it went and it was like 10 times more views. Did it post it to my timeline? Oh, no, it did. It did. That's fine. I guess just day 2 of the same project is all. Okay, so reward here. Ooh. That's interesting. You're not necessarily going to know what the thing looks like until we have elo of some type, because predator prey is an adversarial task. But it does train, so that's nice. Let's see if it looks reasonable. Yes, it does. The red ones are on the outside. Okay, that's interesting. I didn't expect that. So that's probably fine. And so predator prey, and then it was group up is the third one. Group. Which I would hope would be one of the easier tasks. Quick reminder for folks, if you haven't started PufferLib, please go ahead and do that. It helps me out a whole ton. Helps me get all this work out there. That's really weird. Observations.shape. Colors.shape. Buff to observation. Same group. Word. Sum. Diff reward. Can I just do like not like this? Not. I don't know if the unary. Then you got to do like this, right? Yeah, and we get all the different pops. Cool. And let's just open config grid continuous. We'll do this like 20 mil steps or whatever. And we'll see if it actually trains. Let's see if this trains anything. Flat -1 means I'm computing the reward wrong, guaranteed. Let's go figure that out. Oops. Guaranteed means that I'm computing it wrong. What on earth? Okay. Oh, the rewards are being clipped, stupid. Right? Yeah, this is... We can clip them between -1 and 1. Yeah, that's fine. This still might not work, but we'll see. This will be better at least. So it's stuck at -1. Because it can see... It can see other agents around it. A lot of other agents around it that are different pop. Let me see if it's actually flat -1. I think it probably is. Yeah, it's flat -1. Okay, so we need to do... Can I do, like, divide by 50 or something? Or do I do divide by 10 and do, like, -5 to 5? For now. Now it's just stuck at -5. Alright? Well, it shouldn't be just stationary, right? If I divide by 50. Gets worse over time. Well, weird. At least it's not stuck stationary. Let's do over 100. And then let's just clip it from -1 to 1. It's probably the best thing. Well, whether this actually helps, we'll see. I think it's probably getting too large. Rewards. Ah, well. Doesn't have to train immediately. We can always think about why it's not training. We do have the tasks, though, which is nice. Only one I'm missing is the PufferLib task. I'm going to have to decide a few things before I can do that. Yeah, I'm going to have to decide on a few things. So, 1,000 by 1,000 map. Let's change some defaults. I think we want 4096 agents, not 1024. If I do some division, if I do like 1e6 for 4096, 200 tiles per agent, that's plenty. And what we do is we say map size is going to be 1080. Oops. I thought I didn't have render size anymore, do I? Wait, what? Hold on. Wait. Width, height, num agents, horizon. Oh. So it's just going to be width. Hey, I was talking to some dude about your project and whether or not your platform could be used for agent-based computational economics. Yeah, I've had a lot of people ask me that. You can kind of do it. You can get some interesting stuff. It's very hard to train agents to actually engage with a market system. I do have some upcoming work in this area, though. Though the inspiration for it is not necessarily economic. I guess it will be somewhat interesting for that purpose. Yeah. Definitely with Puffer, you could very, very easily write like an RL environment that has those types of action spaces that would be fast enough to train to get some interesting behaviors, for sure. Should the horizon be for this task? It's 100 ticks per minute. So, well, a good way to decide that would be it takes 512 from the center. It's going to take like 1,000 steps to get to the edges. Yannick Kitchler's machine learning Discord. You can get some. There were some things in Neural MMO in the competition, and with some of my other results where we actually got kind of like reasonable looking supply and demand stuff to emerge, where like items would actually just be priced reasonably by the agents. I think some of it was because people were scripting it in, but some of it was definitely emergent. And the problems that we have with a lot of this are less to do with the difficulty of that problem specifically and more to do with the fact that like the market is one small part of a much larger environment, and getting agents to use a market when it's one small part of a larger environment and it's not immediately clear how it's important is difficult. If you just wanted to have like agents to optimize on a market to like observe interesting trends, that would be substantially easier. Okay, so this is a nice little frame. This has 4096 agents in it now. Does that look like 4096 agents? Guess so, right? And some of them are stuck, like they cannot move. because they're blocked in. And they're slowly diffusing over time, you can see. Okay, so this is perfectly fine for now. One aspect we discussed was the dictator's game Nash equilibrium, whether or not agents engaging in sanctions policies would lead to more peaceful behaviors. So the really obnoxious thing about game theory and RL is like we solve a lot of these problems in the real world. Like we break Nash equilibrium in the real world by cheating outside of the game, right? Like we solve one of the things that that's common, like iterated prisoner's dilemma, for instance. We don't necessarily solve that problem in the real world. We solve it by like, making promises or threats outside of that game environment, right? It's not like, oh, tit for tat in prison. It's, hey, if you rat me out, you're gonna get it when I get out, right? Um, so what I would say for that type of a thing is the behavior you're looking for something that is reasonably learnable in the first place? Because you don't break Nash equilibria without having external factors that allow you to do so, generally. There's some work with like AlphaStar and exploiter agents. That's probably relevant here. But it still relies on the game having like some sort of way around it. Did I get this right? Hold on. I think I gotta update the config. Yeah, because we're gonna replace 8 512 agent environments with one 4096 agent environment. So this is gonna be 2 M's, 1 M batch size. This should be substantially better. I still don't know why they're not learning. We should probably do the diffusion task, right? Do we have the diffusion task in here still? We should put like scatter back in here. Because that was kind of an interesting task. Oops. Does it reward introverts? I don't know, I like calling it introverts. It's kind of funny. Introverts. Yeah, let's add introverts back to the task pool. See if it runs. Okay, so this does run. Does it train? Okay, so this does train. Now what we're going to do is we're going to commit all this stuff up and we're going to train it on the big machine. And we're going to figure out why this thing is not working the way we want it to. Okay. This is the i9 13900K machine, slightly worse than the other boxes I have. and the 4090 box. So pull. Skibbity Fortnite. I don't know why that's funny to me, but that is funny. uh... We run this 120, I think 125 mil was the original setting, right? Let's do grid continuous. If this does not hit a million steps per second, then we had some optimization that's wrong. Okay, it's close, but we probably have a little bit more optimization to do because it should hit a million, and I can see that the environment is not at 0%. Though it is decreasing, so maybe. Ah, the reward is actually maybe improving. Let's see. Puff grid. A little bit of patience. Right, the reward is going to end up being cyclic, I think, because at the start of the environment it's bad, and at the end of the environment it's good. So at the start of the episode, all the agents are stuck together, and then they spread out. So this is gonna like be pretty jagged, but hopefully reasonable. Is this SP3 based? It's definitely not SP3 based. This is PufferVec. In fact, this whole environment would be like 20 times slower just because of the petting zoo API if I were using that. This is the advanced puffer version. Nope, the model is not compiled. I can make it faster than this anyways, I'm sure, even without doing that, because I have 1 million plus on Snake. So I'm sure it just needs a little bit of tuning. In fact, let me just look what did I do different with Snake here? Snake has... it looks like Snake just has a bigger mini batch size. Is that all? So... no mevs, no workers. Yeah, bigger mini batch. Which actually means I could probably make it even faster. Substantially over 1 million. What did I do here? Yeah, so 4096 would be the limit, I'm assuming. 42% forward pass, that's why. Maybe this is not learning. Yeah, this reward function doesn't look too good. So the question is, what did I break? Well, we definitely had this learning before. And this should be a very easy task. Well, we'll go look at that, right? First of all, let's just get the speed of this to be something, you know, a little bit more reasonable. And let's just borrow the snake settings, because I'm assuming they're probably going to be decent, right? So for snake, we do a batch size of, seems dated, I'm pretty sure it was larger than this, but 131. We'll use 131K for now. This should be simpler than snake anyways. We'll do 32K batch here. Gamma's fine, this is fine. Entropy is really high here. We do O1 or O2 maybe. We'll do O2. Learning rate of 0.003. It's actually fine. So let's start with this. Okay, there you go. There's your 1 million steps per second. It's funny, we can actually make this way, way faster if we just used more agents. I'm kind of tempted. 32K, reasonable. 32,000 agents. I don't know what would be a good or optimal batch size for this. Just for fun. Yeah, let's not do this tracking stuff, right? Ocean. Let's say that we're going to make this 32,000 agents, right? 32, 7, 8, 7, 6, 8, like this. How fast is this train? Only 1.2. It's kind of weird, isn't it? Forward pass is still slow. Very slow. I wonder if that's the data transfer, right? But I thought I'd optimized it pretty well. Well, yeah, we're going to fix the training separately. I want to make sure that I have the sim running at a good speed first. And that I have it like hardware optimal. 32K agents, right? Why would that be slow? Continuous. I think I defined this as UN8, didn't I? These ob slices. Yeah, vision range is 5. So these observations are very tiny. I mean, I can't say it's very tiny because it's 32,000 times, what's that? 100-ish by 11. So 32 KB, 3 MB. Where's the forward pass time? Oh, no, wait, this is in MISC, right? So the to device time is actually just in MISC. In place update should be faster. MISC is 14%, which is still high. Why is it? Why is it that the forward pass is this slow? It was made substantially faster, right? Before. Training was made substantially faster. Well, definitely some room for optimizations. This was faster than before or no? I don't actually want to mess with the... We're going to take the 1 mil version for now. Because this number of agents can actually start to mess stuff up. Like this can actually start to mess up a lot of tricky to track down things. Just the way the memory works out. Continuous. Mini batch is fine. 8's probably fine, frankly. Grid. Entropy. Yeah, so all these things are fine. So next debug check. Oops, next debug check is going to be the horizon. So we're going to set a nice, very short horizon. Let's do dash dash track as well. I'm going to set a nice short horizon. And that should make it easier to learn a little bit. We will see whether this is the case as a matter of fact. The reward does seem to be improving quite consistently, right? Yes. Is it getting worse again? Or is it just stable? Hard to say. So regardless, though, it is learning something. Entropy curve is fine. Clip frac is a little high, but probably fine. This is definitely crashing. Odd for an environment like this to be unstable. Very odd. Environment like this should be very stable. Does seem to be learning back a little bit. Let's see the curves. It does learn back a little bit. So it's very weird how it's not fully stable like this. You can see the entropy crash down pretty bad. So we'll have to do a sweep on this. And this is on the easy version. The easy scatter environment. Let's see what this policy actually does, right? In this model. Okay. That's actually very reasonable. Wait, hold on. That's very reasonable. Holy. What the heck? That's sweet. What the heck? Yo. Okay, and then like they screw up because they all accumulate on the edge, but that's kind of cool. It's so funny that they just chill down there as well. They didn't learn anything else other than that. Okay, let's actually get a recording of that. Yeah, but did you see the way it separated? It was kind of cool. It like they kind of like did this diagonal separation, so they had like they were moving across each other. It was kind of cool. But I will steal that for I will steal that as a quote. So that is going to be what, 50 frames at 15 FPS. We'll do grid .gif. Just want to watch this thing. It's so cool. Like, woof. I mean, that actually really looks like sand. You're right. That's kind of cool. That's like a really convincing sand simulation, isn't it? That's like if you just hucked a pile of sand, isn't it? This is actually, yeah, okay, cool. That looks really sweet. I mean, it's like a nothing, but it's still funny. People gotta stop liking the stupid post. Bad. Okay. I really didn't expect that. I really didn't expect that to happen. That's kind of weird that that worked that way. Yeah. What do we do next here? Well, because I'll show you why. So before I made this, I messed with this environment, right? I had like a similar version of the same thing. Well, first of all, the reward curves didn't look very good, right? And where is it? Where are my darn posts? Freaking thing. Is there a command? Like, I don't think there's a Twitter command on YouTube, is there? It's JSWARS5341. Okay, so this was the file. Yeah, this grid environment. So this is what happened when I trained it before. You see, like, they end up in these weird clusters. So I don't know what happened, like, what I changed that makes them not end up in these clusters. But this is what happened, like, after I tuned it a little bit with the original version of the project. There are a few different things like this. This is a slightly higher perf version of the above one. So you can see they spread out in two directions, but they still end up in these clusters, these clumps. And then if you use a really expensive to compute reward function, then you get something that looks a little bit more like this. But I didn't want to do this one because this one's really, really slow. Yeah. And centralized Euclidean distance, you get like this thing. And you can sometimes get them to like move in this amorphous mass as well with weird rewards. I guess we can try training one of the other ones. Just to see like how far off base we are. I also want to think about the time horizon a little bit. I think it's kind of fine as is. It would be more stable if I cut the time horizon to 512, though. I'm going to cut it to 512 just while I'm deving. It'll just make it a little bit easier, because, like, they're wasting half of their training data now. Oh, wow, that's funny. So, this was the one that I trained with 64 horizon, and I guess it just generalized. Huh. That's cool. So we'll leave it on this for now, and we'll do, ocean, grid continuous, / continuous. And we're going to change the task to, let's do the foraging task. All right. And we'll see how this one goes. Okay. Reward goes up. Reward does go up. So this will be done. This is 125 million steps training, to put this into perspective. And it finishes in 2 minutes. When I was starting in reinforcement learning, we would train stuff on Atari. People still do this, but we would train stuff on Atari. That was like the most common test suite. And it would train at like 1,000th, maybe a couple thousandths of this speed. So you do a 10 million step run, and it would take like multiple hours to do a 10 million step run. 100 million step run in 2 minutes. Not apples to apples, but very, very nice. This one actually appears to be very stable, at least with the very short horizon that I've given it. So I'm hoping that this gives us some sort of interesting policy. This should be a very easy task, to be fair. No reason for this task to be expected to be hard. But, yeah. We should just get an idea of, out of this. And then we'll run some sweeps and we'll debug the environments and stuff over the next couple of days. And we'll figure out all the questions that we wanted to answer with it about continuous versus discrete. It was a discrete version, just because I know it's going to be easier in testing. But we'll be able to do a lot from here. And that is completed. Let's just make sure it didn't crash. No, it didn't crash. It actually got a little better towards the end even. So, pretty nice. Policy learns in 2 minutes. And we have a model that is ready for us. This is public, by the way, so you can just grab my models if you want. This one's going to be forage.pt. I gotta change the task to forage. I haven't added a hook for this yet, so we'll just do it in the code. I think just grid continuous. Holy. Well, that's cool. Huh. So weird how it does this, like, yeah, I don't know. It's fun. Let's do let's do one other one. A herding task. Your wish is my command. Let me try that one. Because we actually already have it. It's predator prey, which is basically that. Now, the initial conditions for this are a little screwy. Because the enemies start, like, around the prey. So, I don't know if it's going to do anything cool or not. Like, I might have just screwed up this environment. Reward goes up. Ah, so reward going like this is not necessarily bad because it's an adversarial task. So if the prey does better, then the predator does worse. And if the predator does better, then the prey does worse. And actually, the rewards are like one is the negative of the other. So in order for one of them to do better, the other has to do worse. It's. I don't know if it's quite zero sum. I think it might be zero sum. Anyways, I have no idea what this is going to do. So let's see. One of my favorite things about this type of work is you can be really stupid about it. Like, I don't have to know what the hell's going to happen. I just have to make a fast sim, make sure the sim is right. And then, I mean, this is just me playing around with it because it's fun, since I just built it and kind of want to get a feel for it. But I'm going to go run a bunch of hyperparameter sweeps on this stuff, and we're going to figure out exactly how we should be running the bigger tasks, like what settings and stuff. We're going to get way better policies out of it, and then we're going to do some actual science based off of that. So that's going to be real cool. Million steps per second training. Uh, I guess I should emphasize just like how unheard of it would have been up to very, very recently for me to be doing like 100 some odd million step experiments live because they take 2 minutes. Technically, I could load like the forage model with the predator prey task or whatever, but I don't think it would do anything cool. Did you see that? So I guess I did it backwards. So I guess the prey is the red, um, which is kind of better. So the prey, they just like they run off this way, and then the predators go, wait, they're escaping. Oops. Yeah. Well, it's an undertrained model, right? Like undertrained models develop all these weird directional biases. The one I would like to do, actually, there is one that would maybe be a little bit more interesting because we didn't do. There's one other one. Yeah, you're gonna get way better results with longer training, with better hyperparameters. There's all sorts of stuff that we can. This is just like we're having fun here. This is just like getting a sense of whether I made remotely reasonable environments in the first place that kind of do something that looks decent before I go burn some compute on sweeps. It's not even burning that much compute on this. Like what, 10 minutes for 500 mil, something like that. So I can do 12 experiments per hour. So, I mean, I could do, 100x sweep over these in a few hours, whatever. Yeah, we're going to be able to do lots of cool experiments. Like I said on Twitter, we're going to run like 100 billion sweep or something on this, and that's going to be very easily doable. At a million steps per second train. Where is it? Reward group? Yeah. Group. So this one, they shouldn't run away from each other, but I wouldn't be surprised if they do run away. I don't know. We'll see. I don't have to know. I can just run the experiment and find out, right? What are you building? I am building an engine for continuous control with reinforcement learning. It is well, I have some examples on Twitter here that I just posted. Cool to see the first Twitch chat message as well. I just added that as a streaming platform. So I've got these tasks that look like this, where each of these pixels is an agent. This is predator prey, with the gray ones trying to chase the red ones. This one, they're trying to eat all the blue food. This one, they're just trying to get away from each other. And really brand new project. Just started this in the last couple of days. But the goal is ultra high performance reinforcement learning. And there's some additional scientific stuff here. Like I want to do continuous and discrete with the same environments. This will let us gain some insights as to whether training robots is fundamentally harder than like training RL to play games, stuff like that. But we're going to get to that over the next couple of days once this gets a little bit more well built out. It's fun stuff. Probably is the first follow on Twitch. I think you can see the chat overlay. This is multi-streamed to Twitch, YouTube, and Twitter. So the Twitch is entirely new. So thank you for the interest. I don't know how the Twitch page looks. I just set it up real quick the other day. And they take about 2 minutes to train 125 million simulation steps with a little neural network and little LSTM. This one's almost done. Let's actually open up the logs on this to see, did this train anything reasonable? Yeah, the reward went up. Did something, it looks like. So actually, this is not so bad for first try. I haven't optimized anything. The model's trained for like 4 different tasks that I set up. I kind of guessed on everything, and it still works, at least somewhat works. Group.pt. I think Wanby has like Cloudflare or something because it takes way too long to curl stuff. It's 12-second timeout. Okay, so we're going to do group. And did they do anything? What? What? How do you decide an agent architecture? I will show you the agent architecture. It's mainly common sense, but it's highly optimized for speed. This is almost the identical architecture that I use for multi-snake. Actually, we've got the fellow still on Twitch. I'll give you a reason to check out this content. The snake project that I built, this is something I've done that this took like an actual week worth of work. If I can find my snake project. Come on, I posted it just a few days ago. Yeah, okay, so we've got snake, where you have reinforcement learning with snake, but lots of snakes. And this here is reinforcement learning with 4096 snakes. Lots of snakes. Actually, do I have the local one? It would look way cooler if I just opened the local. Let's just do it. Oh, this is one of the GIFs. Nope. Yeah, there we go. Snake with 4096 snakes. Trained with reinforcement learning. So the agent architecture I came up with for that was reused for this project that I'm using now, just to answer the question. It's right here. Yes, architecture choice is very important within some bounds of acceptable stuff. So this is 2 convs. Conv with size 5 filters, conv with size 3 filters. And then there is a linear layer, there are relos in between. The actor and the value function are both individual, just linear layers, very simple. And the nice part about this is recurrent. It does have an LSTM on here. I believe it is a 128-dimensional LSTM. So very, very small policy, 150,000 or so parameters. But the nice thing with it is I can train it at 1,000,000 steps per second. So this thing just inhales data. I trained Snake on 10 billion steps. Of course, it was a pretty good policy after like 5 minutes of training, but for the sake of it, I just kept training it for 10 billion to see if it would learn anything else cool, and it kind of did. And we're using basically the same architecture for this right now as well. So what the heck just happened with this? I did not expect this. The task, at least I thought the task, was for the ones that are the same color to group together and the ones that are different color to spread apart. And instead we have created a water spout thing. And the reward is going up as well, so is it just me, or are they like locally assembling themselves to get close to the same Hmm. Well, it's probably the case that I'm really crunching learning here by making them spawn right next to each other, huh? Why use LSTM versus RNN versus transformer? You never use a vanilla recurrent neural network. Vanishing gradients problem, very bad. It essentially has no ability to train over reasonable contexts. Transformer is heavier and very hard to implement in an RL context because of the way that you collect data. So some people have had a little bit of success with them for like small scale online RL, but generally the standard is LSTM here. Yeah, they can't occupy the same space, Linky, so the same color ones are blocking. I'm going to make a couple little tweaks. Yeah, I'm going to make a couple tweaks. We're going to do... times at 324. It's still good. Did I forget lunch again? I'm going to get this experiment set up to train, and then I'm going to go make myself a shake for like 2 minutes. Keep forgetting to eat, damn it. Man's gotta eat. But I'm going to get this thing to train so that it'll take 2 minutes to train, and then I'll come back and I'll have, I'll have it done. And then we'll finish up the stream. If I don't do it now, I'm not going to have time before my meeting. Where was the was it spawn positions? So this is going to be every 4th position. Okay, perfect. Be right back. Gonna go make my shake. 1 sec. Okay. Missing meals normally is bad. Missing meals when you start your day with 2 to 3 hours of exercise is absolutely atrocious. Let's go grab that policy. Ooh. Well, this is a little bit odd. Do we have a crash? We had an entropy crash. This might not be particularly good because it looks like it was doing well and then we got the entropy crash. But I'll open up the model anyways, and then what I'm going to do is while I am opening the model, I'm going to just train this for longer. So we're going to do 300 mil while I'm doing the analysis on this one. Yeah, I should have time for that. That's fine. Let's do... Oh, it's the same. Yeah. Yeah. The multi-stream thing is cool. Let's see if this does anything. What? Was it just me or did they... Oh, wait, they didn't spawn correctly because I didn't pull that change down, right? What you pass for the target features on unseen new data when the target is unknown. What do you mean the target feature? I don't know what you mean by the target feature. I did, what was it? Star, colon, 4, right? Yeah, that'll work. Oh, wow, that's weird. Okay. I guess that's the starting pattern. Did not expect that, but okay. Hmm. Let's see if we have a better model. This one has been training, right? Does the crash get reproduced? Yes, the crash reproduces. It's interesting that it does. Then it starts going back up. And 938. Yeah, so it's about where it is now. Doesn't really seem to be improving much from here, though. Maybe. 928. Yeah, it was improving back. Okay. Oh, yeah, there it goes. It's a little jumpy. I'm wondering if I specified this task correctly. This was the group task, right? So you get rewarded for seeing agents of the same color. And you get negatively rewarded for seeing agents of a different color. But the conditioning on this reward is very weird. So probably the reason that it's so unstable is that the reward magnitude is too big. I had to divide by 100, and it's still clipping to -1 and 1 very often. Like, this -0.9 is way too big for a reward. Though it does seem like it has gone back up somewhat. And if it doesn't crash right at the end here, yeah, this should be 0.89. Oops. Yeah, this should be good. To there. Perfect. If I refresh this. Oh, yeah, look at that. Perfect. So, let's see what... I have no idea what this model does. Let's see if it learned anything remotely reasonable. And then I'll think about what I'm going to do with this next. And we'll go from there. Continuous files. Copy. Okay. So, again, I didn't mean to have them start like this, but that's weird that they do that. Well, not exactly what I was hoping for. They clearly haven't learned this one. So, the other tasks maybe perform somewhat reasonably. This one does not. The foraging one in particular leads me to believe that they are, kind of reasonable. Yeah. I think what I'm going to have to do with this is I'm going to have to fiddle with it a little bit. I'm going to have to fiddle with the different horizons. I'm going to have to do a couple more of these like experiments type things offline. And then I'm going to have to run some hyperparameter sweeps, get some reasonable defaults, and then hopefully that will be enough to get some visually compelling results. And we can do the continuous versions. Just for the sake of it, let's just see if anything happens to work immediately with the continuous foraging one, right? So I have a little bit of time. And that'll still give me a few minutes before my next meeting. Let's do... foraging. So we're going to do the foraging task because I think that's going to be the most consistent one. And we're going to set the continuous... we're going to set continuous to true. So discretize be false. Action spaces. Oh, right, I didn't add it to this model. Okay, so that's going to be harder. I thought I was going to be able to do that easily. I have to change a couple things to support it in the new model. That's fine. Okay, in that case, then let's do something slightly different. Let's do Horizon 512, 300 mil, foraging, and let's see if it learns anything. And I want to fix the... I'd like to also fix the initial condition. How the heck did it happen to be this? Colon, 4. Yeah, this thing, how'd this happen? -1, 2. I think if I put it here, it'll do it. Yeah, this should do what I want if I put it here, I think. Yeah. Let's try this. And then we'll commit everything up. For new folks here, if you'd like to support my work, all I ask is that you star the Puffer repo on GitHub. Helps me out a whole bunch. I work on reinforcement learning stuff, making everything a lot easier and more consistent and faster full time. That helps me quite a bit. And I also post a bunch of this stuff on Twitter under JSuarez5341, same handle. Let's see if we've got any cool graphs. Okay, so the reward goes up, and then I think it might crash back down. Is that? Maybe. We'll just have to wait on it for a second. I made this longer horizon, and I made better initial conditions. When you spawn all the agents right next to each other and they can't move, that makes it really hard. I think I might want to change this environment up quite a bit as well. The best thing you can do for learning stability with these like big multi-agent sims is to make it so that the agents respawn periodically, so that you get constantly diverse data. Like when you have a big chunk of data that's like all the agents at the start of the end, and then all the agents in the middle, all the agents at the end, that destabilizes stuff. If you can make like a nice smooth thing where you have different agents at different parts all the time, that makes it a lot easier to learn. So like every time it resets here, it screws it up. If I were to just like respawn food or whatever and just randomly spawn agents, that would be a lot easier. Though it is cool to see them spread out like this sand. I'm seeing 001 reward constantly here. How is it that this is so far behind? Maybe it's rounding. X features equals... Hold on, let me see. I just saw your thing. X train equals features. Wait. X train equals features. X test equals features to predict has same shape. Prediction equals... Okay, so the syntax that you're using reminds me of like ML courses and stuff. So I'm not sure if this is intended specifically for reinforcement or for learning or for machine learning in general. But the train and test thing is a little bit different here. So you're interacting with an environment. All of your data comes from this simulator, this game. It has a specific shape. The shape of the data is, in this case, a crop from like the pixels nearby or whatever, if you want to think of it that way. Little 11 by 11 window, so it's technically 11 times 11 numbers. And when you collect that data by interacting with the environment, you're running the LSTM for one time step. So you have a state, you get the state from the last step, you feed that into the LSTM, you feed the current observation in, which is the current set of crops of windows, you feed that in, and then you get the updated state to use after you've updated the simulator. And then when you train this thing, you collect all the data that you've gotten from the simulator, and you put it together into sequences, and then you run the LSTM over those sequences. The source code for this is on PufferLib. You can also see a slightly simpler example in CleanRL. But if you look at like clean PuffRL here, this is my main train script that I wrote for this. It's based on CleanRL. The LSTM call is right... Where is it? Yeah, right here. So the LSTM call is right here. The data shaping stuff is mostly in the experience buffer. But, you know, we have the flattening of experience here, the experience buffer. And then the collection of data with the LSTM and the simulator is you run the simulator, you run the policy with the LSTM, and then you go back to run the simulator, run the policy with the LSTM because the data comes from the simulator. Don't know if that answers your question. Okay, so this trained something, and the reward is pretty static, but the episode return has gone up, which is encouraging. Let's go grab the model from here. Should have saved by now, right? Is there a starter JAX LSTM? This is all in PyTorch. This is million step per second reinforcement learning in PyTorch with CPU environments. So, not entirely sure with the JAX stuff. I kind of did write a big ranty post the other day about JAX pissing me off on Twitter, wherever that went. Right, frickin', where's this rant post? Is there articles? Yeah, here. So this is on Twitter. And a lot of this is annoying JAX stuff, so probably not the person to ask about, you know, what tools are there in JAX. I know if you are using JAX, though, my suggested implementation is the CleanRL JAX versions. Those are pretty nice. Where was that model file? It should have been done by now, right? Here we go. What's the distinction with CPU environment? Does this mean it is one environment per CPU? It could be multiple environments per CPU. The distinction is that the simulation itself occurs on the CPU. So I'm not, the sim itself is on CPU. You could have multiple sims per core. You can have multiple agents per sim, multiple agents per core, whatever you want. PufferLib gives you very, very fast vectorization. But the difference in the way that I'm approaching environments is instead of writing domain-specific language stuff in JAX, where you're very constrained in what you can write by the JAX language, I'm just writing arbitrary environments in Python, which are still really fast, millions of steps per second, and then I have good vectorization code to get all that data onto the GPU relatively efficiently. Very, very flexible approach. And this is the last thing that I've got time to do today because I have a meeting in 10. Got to finish the shake. Got to do a couple things. What happened with the URL? Oh. All this env code, by the way, is open source in PufferLib, so you're free to look at the way it works. There's like, this project is still very new, but there is a massively multi-agent snake environment that's a really fast and a really good demo of this tech. And I have a lot more stuff releasing very soon as well. Training stuff as we speak for it. I wanted to change the rollout length. Didn't I? No, it's good. Well, the spawn is wrong, but let me fix the spawn, because that might actually bias it. Come on. So this : 4 has to go on here. JAX limited because environment complexity is limited due to GPU restrictions like branching. Yes, precisely. Not only is the GPU restrictive in what it's good at computing with branching, but you have to you essentially have to solve a clever puzzle every time you want to write something, because you have to twist your head around how to write everything into array operations. Whereas in Python, you can just write arbitrary code. Yeah, your state is usually still going to be in arrays, but some of it can be in structs, some of it can be in other things, and you can write arbitrary logic over it. You can write loops, you can write conditionals. You don't have to like do everything in this weird functional domain-specific language. Let me do that one more time here. Okay, so this is a little bit better. Actually, we have some agents that go in all directions. It's a little bit less directionally biased. I think we'd have to train it for longer to get it fully unbiased. Useful info, but I'm just self-taught trying to learn LSTM models to shamelessly predict things like stocks. You're going to lose a lot of money doing that. So the way your sequence is prob different, but I'm looking for overlap. Yeah. So this is not classic machine learning. This is not like train set, test set. This is your data comes from a simulator. And anytime you want new data, you have to give actions to the simulator. Like you have to press the buttons on the keyboard to determine what happens next, right? It's like playing a game. So the data setup is very different. The infrastructure setup is very different. Yes, technically the data has to go into an LSTM, and the way that you're going to do that is going to be roughly the same for classic machine learning or for reinforcement learning, but there are a lot more moving parts here. Okay, so decent little progress for today. We did. Let's actually commit all this code up so that you guys can look at it if you want. Why has Jax become so popular in RL, not PyTorch? Because in order to get CPU sims to run fast, you have to do some vectorization work and other things that nobody bothered to do. I did it. It is now in PufferLib. This is very recent. This has been released within the last couple of months. It is incredibly efficient, and it makes reinforcement learning so much simpler. And this is also what I'm working on full time now, so this is just the beginning. I genuinely think that reinforcement learning is going to be a stable, consistent, easy to work in field within a few months, directly because of PufferLib and because all of these simulators I'm building. Like, the default in reinforcement learning is going to be you train at hundreds of thousands to a million steps per second. You have access to a variety of simulators of various complexity for all of your research needs, some of which are more complex than some of the most complex simulators out there now. You have access to large-scale hyperparameter sweeps that run overnight on a single GPU, and you have access to quality infrastructure backing all of this. All of this code is incredibly simple. It's like a few thousand total lines. There are not 500 useless abstractions. It's going to look like CleanRL. It's going to have the efficiency of sample factory or higher. This is where RL is going. Takes some work to get there, though. And with that, I have got to go to a meeting in a couple minutes, so I'm going to sign off. I will probably be back streaming more dev on this tomorrow. And yeah, I've been enjoying this, so I'm just going to keep going with it. And hopefully we'll get some better policies, as well as we'll start doing some continuous control versus discrete experiments tomorrow. See you all, and star the puffer if you haven't already. Helps me out a whole ton. Bye.